Hey everybody, I'm going to do a reasonably quick chapter 16 recap, okay? So, chapter 16 was confidence intervals on proportions. Okay, so let me go ahead and underline that for all of us, and I'm going to go ahead and do a little summary just on this page of everything that we learned in chapter 16. So hopefully this will help answer some questions that might be lingering from last class, or if you missed the class, then this is a great opportunity for you to go ahead and see what was missed. I am not going to, in detail discuss how things are verified or checked, but I just want to give a summary of all the things that we did cover because it was quite a bit. So the first thing that we talked about were that there are three conditions that are required for proportions. Okay, and those three conditions are number one, independence and randomization. So we're looking for the subjects to be independent, and we basically say that if it was random, so if random assignment was used or a random sample, then it was independent. For the second condition, we check success, failure. This takes some calculations to check. We actually have to check to make sure there must be at least 10 successes and 10 failures. So we have to verify that the number of people who said yes is at least 10 and the number of people who said no is at least 10 in this proportion. And then the final condition is the 10% condition, where I don't know why I switched from these to a colon and now back, but here's where we check that the sample size N has to be less than 10% of the population. Okay, and this is another one that's a little bit tricky to check, so you may want to go back to some examples online or even reading those early explanations in your MyLab homework because they do check the conditions for each one of these problems. Okay, then we got into what a confidence interval actually is. So again, this isn't an introduction, this is just an overview. So remember that we created a confidence interval, so they're used when we don't know the population proportion. So we're not sure about the percent from the population, so we estimate with p hat, which, just to remind you, was the fraction x over n. So that's the number of people who said yes over the total number in the sample. So if we're checking successes up here, that's actually x, okay? And the number of failures is n minus x. And then we did our one prop z interval, which looks like this. P hat, or our estimate, is in the middle, and we add and subtract what's referred to as the margin of error, okay? And then we end up with an actual interval, like old school interval notation, a lower bound and an upper bound. So it's the sample proportion plus the margin of error. And then I take the sample proportion and subtract the margin of error and I get the lower bound. So I basically add and subtract the same number to this value and I go on either side of it for a lower and upper bound. So reminders, there are actually two ways for us to find the margin of error. We could take our z star critical value, which we have a table of those values, and multiply it by p hat times q hat all over n underneath the square root, which is referred to as our standard error, or SE, okay? That's what we call p hat, q hat all over n. And this was just an estimate of the standard deviation because we don't know p and q. And then the other way is that you can actually find the margin of error by doing the upper bound minus the lower bound all divided by 2, if I know the interval first, okay? And then just so we're all clear, in the calculator, it's a one prop z int, okay? And the input that you're required to have is x N, and a confidence level. And the output we get is a lower bound and an upper bound, which is equal to our confidence interval. Okay? So the very last thing we learned was how to use the critical value and the margin of error to estimate a sample size. So I have a confidence level provided in the problem, and each confidence level has an associated critical value to go with it. This is a z-score that has this percentage of data in the center of the distribution. So this is 90, 95, 97, 98, I need more room, and 99. These are the typical levels of confidence we would see in my class. The first z-star is 1.645. This would be 1.96. So this is where we get 95% of the middle lies about 2 standard deviations away from the mean. This one is 2.7, 2.326, and this 99 is 2.58. So if we need these values, which we do in the next formula for this, the final formula in this chapter, we would grab them from this table. So the final thing we do, if we need to estimate a sample size, that's N, for a given confidence level and margin of error, okay, we would use the following formula. N equals, it's a little ugly, but z star squared, and then it goes p hat times q hat all over the margin of error squared, okay? And then whenever we use this formula, we always round up for this answer. Okay, and that was an incredibly fast recap of chapter 16. I will go ahead and scan these notes and add them underneath the video so you can have a look at them if you need them. This is all the concepts that we've covered in chapter 16.